Okay, well, I'd really like to thank the gentleman who switched to the other room so I could sit in my easy chair and nurse my busted leg, which still hurts. I've got a brace on it to try to reduce the swelling and protect me if I take another spill, and a set of crutches beside me. And it's no fun when you tear things in your knee. This talk is sort of a trying to help folks figure out how we get ham radio groups to advance. I'm not the greatest at it, but we've made a lot of progress in our early ham radio group. And I don't want to come across like I'm an expert at this kind of stuff, because trust me, I am the last person that would ever get picked to be a leader of any social group. That's just not what I'm good at, but there wasn't anybody else. And so I had to work at it. Um, so, what are we trying to do in building emergency communicators? And again, I can't hear the audience very well, but if anybody's got a question or something, just go ahead and get Daryl to interrupt me, and we'll be happy to take your
Or
questions.
let's
What
just
are we?
say, let's go ahead and just say questions to the end. And everybody
Okay,
just write
that's
down
fine.
your questions, everybody, and we'll have them at.
That's fine. So it was said, and I don't know if this is true, but I heard through the grapevine, because a lot of this stuff never gets published, that some of the volunteers that were sent to Puerto Rico had difficulty figuring out what to do with the 40-meter pre-cut dipole that they were sent with. How did they get this to work on 20 meters? So I understood that they had to be explained how to change the length and make this work. Of course, you just get it to be half the length, right? You can fold it back on itself, you can cut it. There's lots of ways to do it. I don't know if that's true. But what we're trying to do with emergency communicators is make people who can survive on their own. You're out there by definition in a place where there isn't a cell phone and there aren't internet. And if you can't make the radio work, you're just lost, because you can't get anyone to help you. So there is no advice available, and you need to be able to figure out almost any normal problem by yourself. There's likely very little electrical power. So if you can't figure out batteries, generators, fuel systems, or if you blow up your radio by getting the polarity backwards, you're just out. You're gone, not going to be an asset for the people you were trying to serve. When you're dealing with an emergency situations, the power that does exist may well produce noise, lots of it. So you need to understand inverter noise and techniques to solve inverter noise, because there's an increasing chance that people around you are going to be running generators like this one in the picture, a champion inverter generator, and it's just a jam up, wonderful spark transmitter. This thing can transmit all over the HF spectrum and potentially beyond. There's not going to be anyone there to teach you what propagation is like. You can't get the ARRL bulletin tell you which bands are going to work. You can't get to the Australian site to discover what the maximum frequency utilization is. You can't get to the Ionoson sites. You got to figure all this out on your own. So you got to know, well, what is going to work and who can I call? So if you don't know what frequencies to use, where there are nets that you can get help from, how to reach the government. If you don't know these things, you're just basically not going to be able to serve very well. So we try to produce people who can handle all of these problems by themselves. If you're given a lengthy list of details that needs to get transmitted, survivors, drugs needed, supplies needed, are you going to have to do that on voice? Can you fix that antenna? Can you adjust gain? Can you make any more gain? Can you figure out which polarization you want? Can you deal with all of these issues and maybe common mode current that's bedeviling your setup and causing problems? All of this, you've got to do it yourself. If you happen to be at a site that has multiple transmitters, you may find that just like in field day, they're desensing your receiver. Can you fix that? Do you know how to create some stubs? How much separation you need? Where to put the antennas? Any way to do some filtering? What if your cables start to be flaky, or you can't figure out why there's no power getting from here to there? Can you fix the connectors? Do you have a way to even figure out what's going on? So those are the kinds of things we're trying to do in ham radio. Almost everybody has a radio these days. So we're no longer that special. We're only special when their radios don't work. And whatever caused their radio not to work might also cause ours not to work if we can't work it out. So you need to actually know something. So we started in the year 2016, about 9 years ago, working on improving our local cadre of volunteers. I'm going to talk about the things that we did to build up a stronger group, how we turned digital communications to our advantage, how we had to deal with horrible problems at our EOC brought about by people before us who really didn't know how to figure out these things, all the coursework, the tricks that we've used to try to build traditional ham radio knowledge into people who are not engineers, not technician kind of folks like us, how we split off our own field day team, and what we do to try to build a real team. Because when you're in a bad situation, you really need a team. Even if you're the only one of the team that's at that particular location, you need to be part of a larger team to make it all work. So the very first memories that I have were that there were about 5 very lethargic volunteers in our local ARRL group. They really weren't connected to anything in emergency communications. I wasn't clear what they were getting done. I heard that at times there were only 2 of them. Their skill set had only one skill: press the mic button. It was pretty sad. They were totally dependent on repeaters. There was no HF effort at all. We held a beginning exercise in May of 2016, and a grand total of 2 people showed up. So it was pretty sad beginning. No HF skills. There were 3 local FM repeaters, which actually in those days were pretty reliable. That's not always the case now. We're starting to have reliability issues. No HF antennas. They were meeting at this building that's shown on the screen. It's a Red Cross building. It's actually a rented building that used to belong to a church. We spent about a year discussing where we could put an HF antenna. It was a very lethargic group. It was very hard to get anybody to agree to anything. We finally put up a very slow antenna, maybe 8 feet off the ground between buildings in this red area right here, and it was a complete disaster. It made a great dummy load. It was so close to these buildings and couldn't even get above the buildings that we basically had almost no propagation. It was pretty sad. We couldn't get any liability insurance because when you're an ARRL group, you're a program, you're not a group. You don't have any legal standing. You don't have any way to get insurance because there is no group. You're a program of the ARRL. And that's a fine thing, but it doesn't allow you to get any insurance unless ARRL is willing to cover you. So the way we got around that was we formed a club. It only takes 4 people in FCC. And we formed a second club. So we had 2 clubs, 2 licenses, and we used one of those clubs to get us liability insurance, and we used the other just as a backup. So now we had liability insurance, and there are 2 insurers that would provide coverage for ham radio groups. And we just picked the cheaper, and sometimes we go back and forth. But that allows us, if we're running an exercise and we don't have county blessings on it, we can easily run our own liability. We've been able to get facilities because the owners asked for insurance, and we said, no problem. Call up our insurance, get a statement of co-insurance for the person, and we're done. So it was $200 a year. We passed the hat in our group, raised the 200, and away we go. How do we begin to get people to be more skilled? Well, what I found, this was 9 years ago, and digital stuff like WinLink or PSK, those were very new back then. In fact, I didn't know anything about them. At the very beginning, I couldn't even teach the technician exam because I didn't understand some of the questions. They had all this stuff about AX.25. What was that? When I finished high school in 1973, that didn't exist. And I went on into electrical engineering and then into medicine, and I was way too busy to be part of the packet revolution in ham radio. So I just didn't know any of this stuff. So I had to go read and study, and there was almost nobody in my city who knew how to do any of this. There was nobody who knew how to do WinLink. There was one person who knew how to do APRS, but he didn't know how it worked. He just had this radio, but he let me look at it, and I got more clues from that. In March of 2016, I was approved as the first ham radio HF WinLink RMS in our section of Florida. KX4Z went on the air as a WinLink RMS. And it's been on the air, give or take a few hours where things broke ever since. So it's about 9 years I've been doing that. I wanted to be more connected to potentially even the government because I wanted to make sure we could actually do something. So a few months later, I became a shares HF WinLink RMS also, NCS 521, and it's now NND4FL. We now have like 7 or 8 of these throughout the state of Florida. We're one of the leaders in having HF shares WinLink stations, and I helped mentor some of those into existence. But back then, we had almost nothing. Now it's a pretty widespread group. I would show up at an ARRL meeting, which were pretty boring in those days, and I would bring a 2-meter transceiver like a Baofeng and a little signal connection system between that and my computer, and I would start making digital connections. And people were fascinated that what is he doing? And they would crowd around to watch what I was doing. In those days, the signal links had just come onto the market, and they were quite pricey for us back then before inflation hit. There was a lot of interest in this. I learned how to use LIN-BPQ, Raspberry Pi based digipeaters from John. Oh, what's John's last name? G8BPQ. He's just a wonderful guy, just a wonderful guy. And he answered questions directly for me and helped me figure out how to get these things going. And pretty soon we had some of these packet digipeaters in various houses across our city. To try to build electronic skills, we tried to solder together our first signal link equivalents, I call them, interface circuits. All of the manuals, printed circuit board files, everything for this kind of stuff is on our website. We've moved our website to nf4rc.club. So WordPress site now, it's much slicker than what I had before. We have just all kinds of free information there. A fair number of our people began to gain digital skills. And so that was sort of the beginning of the revolution for our group. I have some pictures of some of the early systems. Don't know if they were in this talk or not, but it was pretty simple stuff. Raspberry Pis, plywood boards, very simple transceivers, just regular old 2-meter stuff, very simple stuff. Then I took a look at the Emergency Operations Center, which had one radio, which was an old Yaesu Series 600. It was a commercial Part 90 radio, very hard to operate. And you couldn't really make a contact with it. They had one short vertical antenna bolted to a fence outside the EOC. Oops, sorry. I did it again. And it had inside of it for a matching this kind of a transformer system, which has been studied. It's a Comet antenna and it's very high loss. And that's how it makes its SWR look better. This is one analysis here of the of that common antenna versus just a plain old vertical, this is like negative 24 dB comparison between a plain old vertical and the common antenna. Even at its best, it's several dB below just a plain antenna. So this antenna was a disaster at our EOC, and it was the only one they had. But on top of that, the whole building turned out to just be a noisemaker. And we had so much RF noise that making a contact on any frequency below 14 megahertz was impossible, just utterly impossible. And on 14 megahertz, you could hear signals, but you generally couldn't connect to them because your antenna was so poor. I had trouble measuring the noise back then because I really didn't have very good equipment. But this is data that I captured in the year 2019. This is the kind of signals that I measured at my house. And you can see a fairly low noise floor, and you can see obvious broadcast and ham radio stations. This is the 40-meter ham band. This is the 80-meter ham band. You see obvious signals everywhere across the spectrum. But when you look at, I got to move zoom out of the way. When you look at the EOC, the noise floor is so much higher that you basically don't see any signals. And this is when it's tuned for 40-meter operation. This is when it wasn't tuned. It's the antenna is just terrible at that point. And we basically are trying to operate in an extraordinarily high noise situation. In that year, we gained permission to do some tests. And one of those tests, we operated the spectrum analyzer out in the parking lot, and we were stunned to discover that the noise was basically near field in nature, and it declined at the rate of R to the fourth power instead of R to the second power. And that meant if we could just get our antenna away from that building, we would do much better. So this is data taken after we put our own antenna up in the woods just south of the building's perimeter. We got permission to put an antenna in adjacent woods. And you can now see that our current noise floor is way lower than the previous noise floor. And now you can see real signals. So we finally had an antenna that was far enough away from the building, and we used common mode chokes everywhere we could because the whole building is just creating noise. But we now have an antenna that will work. We are not the only EOC that has this problem, because EOCs tend to be built with lots of UPS, huge backup systems, like multi-kilowatt backup systems, like multi-tens of kilowatt backup systems. And they make enormous amounts of noise. And when those don't do it, some people have had air conditioner motors, the new ECM motors. They're just another noise generator. So we have all kinds of noise sources that you had to contend with. And we succeeded. We actually got an antenna that would work for us. Well, then ARRL is chock full of courses for people to take. So they have all these courses, ICS, FEMA courses, basic courses, task books out the wazoo, and they keep changing them from time to time. Florida had a great set. A lot of effort went into figuring out good things for people to train on. And most people don't take advantage of it. And they're actually pretty good stuff. The ICS courses are very simple. They explain to you how the government plans to configure a rapid response system. And if you understand that, you fit in a whole lot better. You're not just off in a corner of the radio guy. I took the whole professional development series, so I kind of understand how a new EOC employee thinks, because generally they have to take the whole series for their salary line to be supported by state grants. So having taken those courses, I kind of know the lingo that they're going to use, and I can point to things like volunteer coordinator, which is a recognized thing that we need. and say, this is a FEMA idea. I didn't come up with this. This is FEMA stuff. So not everybody in Aries does this, but it's a big advantage if leadership in your group will actually take the plunge and get a bit educated. It's just a few hours of time to go through all this. The ARRL had some fairly antiquated courses. I've not taken their new versions, but even their old version had some nuggets of useful information. I had no idea there were all these government radio systems for disasters. They may or not be useful, but at least I knew about them. And I believe the ARRL has improved these considerably. So for our people in our local group, in order to be a real part of our group, we asked them to take IS 100, IS 700, and this has now been replaced by a new ARRL thing. We asked them to upload their certificates to CertTrack, which is being upgraded to a different system now, so that's not necessarily good for us. Fill out a couple of authorizations, and then we can get them into the whole system. If they want to be leadership or be involved at the state or national level, we ask them to take some additional courses. And I went ahead and took all of the professional development series, and I learned a lot, and I think it was worth my time. Where I really focused with our group is on building things. We have a lot of ham radio operators. Over half of the ham radio operators in the nation are technician level operators. And they really don't have the traditional level of technical knowledge that we're used to in ham radio from those of us who started much earlier. Part 97.1 states that the goals of ham radio include a voluntary non-commercial communication service, particularly for emergency communications, the ability to contribute to the advancement of the radio art, which Osher is busy doing, advancing skills in both the communications and technical phases of the art, and building people who are basically experts at communications. And that's sort of what we need to do. So in the very early years, I focused on building radio assets that we all needed badly in our city, because everybody was stuck on rubber ducky antennas. These are just not going to cut the mustard. So we learned how to build Slim Jim antennas, even out of simple wood frames, 1x2 wood from Home Depot. And we actually had one of these in use during a hurricane because there was no other antenna that could communicate from that particular shelter. In those days, we helped a lot of people put up antennas because it seemed like a lot of our hams did not know how to use slingshots or bow and arrow or pneumatic slingers or anything. And so we spent a lot of time helping people get assets so they could actually have effective communications. This is a picture of one of our early digipeaters. It's pretty primitive. A battery as a backup power supply. It gets powered by an external source that keeps the battery charged and provides power for a simple radio. The old analog radios work great for this. A Raspberry Pi that gets powered off of a battery with a 12-volt converter somewhere in here. A homemade equivalent to a signal link and a shielding container that came from T. So it's very, very simple systems. By the year 2017, we were starting, to work on mesh communication systems. And we actually made a 6-kilometer contact. Within a year of starting this, we managed to make some distance, but it's very hard to do this at 2.4 gigahertz in Florida because our leafy vegetation just kills these signals. Irma came along that year, and our part of Florida was the stopping point where everybody ran out of gas. We were staffing 9 hurricane shelters. In that year, we also did an exercise where we drove all the way to Steinhatchee and practiced communications there. This is one of our first printed circuit boards. People would show up for our first building sessions with Weller 100-watt soldering guns. It was pretty sad. We discovered by using printed circuit boards, we could dramatically speed up construction and reduce errors and make this an awful lot easier on our people. And it didn't take me long to learn how to use some free software systems. At first, I used American PCB manufacturers. They're very, very expensive. And then I learned how to use some of the Chinese suppliers, and they're very cheap. And the boards come back to you in 6 or 7 days from DHL. It's just astonishing how cheap and how quick. We worked on battery antennas, infrastructure in those days. So this was on the top of one of our towers. We were 117 feet in the air on the top of a dormitory. And the Weller soldering gun guy turned out to be the hero because heights didn't bother him, and he could put up those antennas pretty easily. That's one of our new antennas right there. And I can't see exactly where it is, but I think there's another on the other side. A local ham taught me how to attach this bar to the tower. I didn't know how to do any of that, and other people helped me out, covered for where I was weak. I was so scared on the top of that. All I could do was set my fanny down on the roof and scoot. I was terrified to even try to stand up. And the Weller soldering gun guy, he got it all going. So anything that we could find that was simple, cheap, and useful, we would turn it into a project and we would build it. So this is us building simple lightning arresters made out of $2 to $3 gas discharge tubes that you can buy from Mouser or Newark or DigiKey, and they work every bit as good as the commercial ones, and they're like 1/25th the cost. And they also will help you stop EMP. And the QST set of articles on EMP, that's what they told you to use. So anything simple, we turned it into a project. We built 4-to-1 balance, which allowed people to build off-center fed multi-band HF antennas. The one I chose was pretty sad. It was a voltage balun. I didn't understand the advantage of a current balun. Van Chesney, AC4QS in our group, kind of said, let's try this. And when I put it on an analyzer and looked at it, it was so much better than what I'd been doing. We immediately switched, and everything that we built from then on was built with Quanella, dual core, current balance, almost no loss, like tiny fractions of a dB of loss. Amazingly good. In those days, we held a lot of license classes. Unfortunately, we haven't done as many of those recently as we need to, but we did everything we could to get new people into ham radio. But what we found out was not a lot of these people would stay with us. Public service and being willing to volunteer, this is quite a different thing from just being a technology nerd. It involves giving up your time and heading out in bad weather, making your family safe first, and then going out to help other people. We refurbished our Beatty Tower packet system. We have a dual packet system with potentially 2 frequencies available there. It's not used as much now as it used to be because we now have VARA, and we have a VARA digipeater at 550 feet, thanks to another ham who helped us out. But any of these projects we took on and we did them because our people learned from them, and we developed more expertise and more capabilities. There was a beloved wood bookcase at the EOC that had been built by another ham. And I wanted us to have a go box for our radios. And another one of our guys built us a matching wooden go box that fits perfectly in the space of that sentimental value bookshelf. And yet you can pull it out. It's got front and back, and you can pick it up and walk off with it. And we've done that. We've since had, the big plastic gator boxes, but this is what we started with. Simple projects, 9-to-1 balun, very simple project. Measure the loss on it, measure the SWR, show that it's useful. You can use it very easily. And then in the year 2023, this gentleman, Stuart Reisner, who knew how to weld, went to work for us, and we took an old equipment loader trailer and welded on a tilting base and managed to get our first tower. And then people found an old beam that nobody was using that we could have. And we had to refurbish that beam, and we got our first directional antenna. Our EOC only had one coax cable for HF operation. We were really stuck because there was only one penetration and it was full of other antennas for professional use, and we only had one penetration we could use. So we started learning how to build HF filters. We took advantage of the VA6 AM triplexer, and we began to improve it and expand it. And we ended up going to 4 bands and then 5 bands and finally 6 bands. We built our very first bandpass filters. These are very simple Butterworth filters. They're not very good, but they were better than what we had before, which was nothing. Our own printed circuit board, and we could at least start to have more than one station on a band, or we could have multiple stations on a field day without having to have their antennas all over creation. Almost all of our projects are documented. I mentioned this once before, but believe it or not, there's just megabytes and megabytes and megabytes of how-to manuals, how to build manuals on our website. This is our first directional antenna. I had never put a beam together in my life before. Most of the other people in our group hadn't either. And this is the tower, the tilting tower that Stuart built for us. And we don't even have a winch. It's real simple. You put your arms up and you walk towards the hinge, and it pushes the thing up. 3 guys can easily push this antenna up. 3 guys can easily take this thing down. And then we crank that tower up, and it's got a rotator, and we've got our own directional antenna. And because of our multiplexer, we could put 3 stations on that antenna, and away we go. Our people began to learn more and more and more about antennas, in-fed, off-center fed, center fed, window line, coax, you name it, we've done it. And so the more I can offload this to other people and get them to learn. This year we did the Arduino WinKeyer project. Most of our group cannot do Morse code. I'm one of the few that can do Morse code at a good rate of speed, but they were so fascinated. They all showed up, and we have built about a dozen of these things inside our group for dirt cheap compared to the way they sell retail. In the process, our people just learn. I mean, they don't know what resistors look like. Are capacitors polarized? Is this capacitor polarized? They don't have a clue. And so they learn all this stuff in the process. It's amazing the amount of just simple electronics that you can learn from simply building projects. When we got that beam, it turned out the traps were full of gradu, just dirt, and nothing was resonant, and it just didn't work at all. We had to take all the traps apart. We had to clean them out with vinegar and Coca-Cola and put them back together again and try to fix broken wires and retune them. And oh gosh, you can see our trailer there in the background with the hinge system that was built. This is all removable. It can come off the trailer and go to another trailer if we had to, if it's similar dimensions. But everywhere we could, we did projects. Someone then gave us a 6-meter King conversion of an SP220. Oh, I hate to see a 220 have that done to it, but it was given to us. And so we then refurbished it, and one of my volunteers put in a whole new power supply, and we have a 1.5 kilowatt worth of 6-meter amplifier, and it actually works. It's almost to completion. It's far enough along that we can operate it. In the year 2020, we split off. This was a big step for us, and we formed our own field day team. There's a legacy club, and they were not very happy when we did this. But we had real problems with the legacy club because they're nice people. It's a great club, but they're sort of the committee of no. They don't want to do anything different or new. And so that didn't fit with our group trying to grow. So in preparation for this as a leader, the first thing I did was do it myself. So the year before this, I did my own field day in my backyard in a travel trailer. And so I had to learn how to do all the parts that the club had been doing for us, did my own field day log, learned how to submit it, learned how to do everything myself, and discovered this is not hard. All of this can be done. And so with that confidence, our group held its very first field day. We went as 2F, two transmitters at an EOC location. We had generator powered travel trailers. We used the improved antenna that we had built at our EOC, and we had our own extra antennas. At that point, we did not have our beam. We treat our field days like a disaster exercise. So there's a lot of planning that goes into it, which was sort of anathema for the older group. We have a lot of evaluation afterwards. We produce a full after action report every year. All of these, you can go to our webpage and read every one of them. They're basically unvarnished. You get the whole truth of what we did right and what we screwed up. They allow us to find our problems and start to improve on them because we're pretty honest about what we did well and what we did badly. And if you don't do that, if you're not willing to write down and keep it for next year, you just don't get any better. So our first field day, this was a drawing of all the equipment and stations and antennas and the things we were going to put together to do microwave mesh logging, stay away from the EOC networking systems, which are somewhat more secure. Our group, believe it or not, wanted a full dress rehearsal. They wanted to set the whole thing up twice, once as a dress rehearsal and once for real. And we did it. That first field day, our people were so green. We just didn't know hardly anything. But we made 0 Morse code contacts, 12 phone contacts, and 237 FT8 contacts. For our city, this was remarkable. This was a huge advance for our city to break 200 contacts. We wrote up a full after action report and improvement plan. There were 62 items in that needed to be improved. That's how much we had figured out we could have done better. By 2024, last summer, we had our own tilt-up telescoping tower, a 3-band, 3-element Mosley Yagi. We had multiple generators. We had our own diesel generator. We had acquired a diesel generator because they don't make any radio frequency interference at all. They don't have anything electronic. They're governor controlled. They're not electronically controlled. They run for hours and hours and hours. They don't make noise, and they don't use much power. We had our own antenna multiplexer by then pretty much completed. We knew how to do RF measurement techniques, spectrum analyzer, nano VNA. We had our own bandpass filters. We had our own 2.4 gigahertz mesh networking now pretty much worked out after a couple of years where we had our own issues. We built our own satellite NTP time server. It gets time from GPS satellites. We're completely independent of the internet, don't need it for anything. Taught most of our crew FT8, and then some of our competitor types pushed us to start doing FT4. We taught most of our crew how to leverage canned text outside of FT8, and we had folks recording voice CQs so they could save their voices. Well, this is the result. I'll move the zoom out of the way. As you can see, our first field day was pretty sad, but every single year we are growing. We didn't grow quite so much that year, but we made up for it the next year. And this last year, we had over 1,600 contacts, which for us was astonishing. I myself had improved so much that I made almost twice the contacts myself as our entire group had made in that year. So, and I've watched our members double and triple their number of contacts, just get so much better at this, become so much more agile, be able to use so many more techniques, be able to deal with so much more systems, and always something breaks and we have to fix it during field day, and our group responds and manages to make it work. Every one of our after action reports is available. I'll probably flip to that page after I finish this. You can read everything that we did right, everything that we did wrong, and how we got better at doing it. The last thing I work at, I'm really not that good at this, is trying to build a team. I think one of the real strengths of the Legacy Club in our city is they're very, very good at social team building, and our group is not quite as good at that. We do this by having lots of building sessions around my kitchen table, huge camaraderie. There's no way I can answer everyone's questions. So everybody helps everybody else. That's the only way it gets done. We work these contests together. We set everything up, tear everything down ourselves. We've gotten to where we can set up a field day in under 2 hours, tear it down in under 1 hour. We ask people to be accepting of training and accepting of constructive criticism. That's not always easy, and we don't always succeed at it. We're involved every Wednesday in state and national drills down at our EOC, and we have a good cadre of team members that participate in that, and so their skill levels just keep going up. Ham radio is a tech-heavy vocation, well, not vocation, but avocation, and it attracts very bright people. Most of you are extremely bright people, but a lot of us are loner types. There might be a slight blush of the autism spectrum in a few of us, maybe, huh? So clubs and journals tend to have armchair experts who are very heavy on opinion and very light on actual experience themselves. They may have practical experience, but they can't explain it in terms of electromagnetic theory. Some folks don't take improvement suggestions very well. So our group has not been the best at growing. We've reached kind of a plateau of about 15 people who are pretty seriously involved. And then others just cycle through us. They come in for a year or two and then they kind of leave. But we generally are managing to deal with most of our attrition through new folks who are just fascinated at the technological expertise of our group, the competitiveness of our group, the service-mindedness of our group. So we managed to keep folks going. This is our Florida QSO party. We didn't make that many contacts. It was the first time we'd ever done this, but this was our team. And we piled into several vehicles and we drove to a park and we set up 2 systems, an antenna between them in like 14 minutes and had ourselves on the air. We stayed there for an hour or two. We had a lot of fun. Unbeknownst to us, we also picked up a bunch of ticks. And then we tore everything down in about 14 minutes and drove to another park and set up, actually, this is the back of a Hardee's, set up again in 14 minutes, got some new people on the air who'd never been on the air before. And that's part of our team building efforts, trying to get, everybody's different. We're all kind of weird. We have our little rough spots. And by spending time together and helping each other out, we get to work together as a team. For emergency communications last year, we always keep track of our data. Our team actually made more than $60,000 for our county in the year 2024 because volunteer time in a federally declared disaster counts as match. And there's an 8-to-1 federal match. So for every time that one of our volunteers works an hour, estimated pay scale of $18 to $20, they're actually making 8 times that for the government because we're all volunteers. So our county, it will take years to get that money. The government's very slow, but our team is extremely well trained. If we were younger folks, we would be completely ready to head to Puerto Rico. We're way overtrained for most of what we do, but that means that we handle issues easily. At one of the recent hurricanes, the antenna simply on the building wasn't working, but our volunteer whipped out an SBR meter, diagnosed the problem, come up with an alternative antenna, got it installed, and away they went. And that's what we're looking for, people who can take care of themselves. It's basically part 97.1 in action. We offer a lot of advantages, and I think these are things that draw people to our club because every club's different, and we have our strengths and we have our weaknesses. We keep people's brains humming. I tell them often that we're an anti-Alzheimer's therapy group, cleverly disguised as a ham radio club. We try to get as much social involvement as we can, but a lot of us are still teaching or working or doing something. So we're not the greatest at that. We tend to be competitive, goal-oriented people in our group. So we have drawn people who were not that happy with the legacy club in town, which does a great job at other aspects, but they're not very competitive. And some of the more competitive types prefer to be with us. The public service folks, the police, the fire, they have umpteen zillion dollars worth of systems these days. They have towers everywhere, repeaters everywhere, fiber optics, you name it, they've got it. The cell phone people have been charging everybody $100, $150 every month for years. And so their stream of income is almost limitless. So they have a huge infrastructure installed. There's no way that we can compete with that on a basis of throughput or bandwidth or coverage. The basic need for ham radio and emergency communications now appears to be when all that other stuff quits, because it sure can quit. Our EOC had no internet just recently for a while. The 911 system quit. Our infrastructure is so complicated, it's often very fragile. So when we take seasoned operators who can operate on simplex, come up with ad hoc solutions, that might not be needed much, but when it's needed, it's really helpful. The things that have helped build our group are projects, training, and exercise competitions that interest our people. By documenting the fact that we're making money for the county, it offsets some of the fact that they put some effort into us. They really have. They put a lot of effort into us. We don't need FTE from them. We need assets, antennas, radios installed at shelters, that kind of thing. We try, not always the best at this, to provide the needs of our members for social connection, significance, meaning in life, and above all, we try to always have fun. So that's what I had for that. I'm going to try to show you just a little bit of our website so you can see just how much stuff we've got. So this is our homepage, and it hasn't been updated a little bit. There's our winter field day after action report. So I'll go there, and it comes up as a PDF, and you can just scroll through it. And I try to stick pictures and documentation of what we did and how we did, and pictures of everybody doing it, organize it along FEMA standards. For when you show this to an emergency manager, they know exactly what they're looking at. They're stunned that you're producing documents that look exactly like their documents and have even more information than what they're used to providing. So we can categorize everything that we did as just as well as they can. I'm going to try to drop down. I don't know if that's going to work so well. But we document, like, this is the number of contacts per hour. So you can see when we were doing well and when there wasn't anybody to talk to and we all went to sleep. You can see some of the problems we had. We have standard FEMA documentation of how well we did at various things. And we will also have, I'll drop down to it, we have a hot wash session. And in the hot wash session, every single comment that people make gets logged. If they tell us, hey, I had an issue about this worked really well, or this worked really poorly, it gets logged because we go back through those, and that's how we figure out what we're going to do to get better the next year. So that's our hot wash documentation. And then this is our improvement planning. We have, I forget, I think 24 different items to improve for next year. We had problems with some of our filters. We need to improve them, get some of the losses down. We discovered some batteries that worked great for us. Some of our planning documentation was not the best. So everything is written down so we can find it. And then I want to show you. We have every one of our exercises that we've ever done. There's a write-up for every single exercise. And they're all very candid. We also have a similar write-up with a different format for every hurricane. So for every hurricane, we will also have an additional document that is our breakdown of how we did as a volunteer group for that. And it's similar to the field day write-ups. It's just organized a little bit differently because you write up an exercise a little differently than how you write up an incident. So all that information is there for you to take, and the how-to documents, educational articles. There's just a never-ending stream of articles of things we've actually done and whether they worked or not and how well they worked, how to build them. Many times you'll find the code, you'll find the printed circuit board documentation for how to build it. All of they're available for anybody to do. Okay, that basically concludes that. And so I will see if there are any questions.